For lesson 6, factoring polynomial expressions, part 2. So now it gets a little tricky because we got the big guys in front. We're not just x squared, it's 15x squared. Okay, so in this lesson we extend the factoring of polynomial expression to examples where the leading coefficient is not 1. So just like with factoring in general, guys, remember where the leading coefficient is 1, it's a nice easy factoring. When it's not 1, we have to do decomp, right? Remember? And so what happens is it makes your possibilities go up in terms of what it can be. So some of the examples require an understanding of the rational zero theorem. These examples can be regarded as enrichment for students following the Alberta. So this is enrichment in the sense that you could see this in a diploma as an excellence question in that sense. Okay, but let's look at this one. The factors of polynomial 15x squared minus 34x plus 16 are 3x minus 2 and 5x minus 8. So state the zeros of this one. So the zeros of this one are 2/3. Right? Add the 2, divide the 3, and 8/5. So what do you notice about the constant term in the polynomial and the constant term in the factor? So 2 and 8, okay? So -2 times -8 still gets me the 16, right? Okay. What do you notice about the leading coefficients of the factors? 3 times 5 gets me the 15. So we have that game with both situations now. We don't have the nice x times x times x. We have to have multiples of the x's and the multiples of the constants to get the n's. So let me say what I'm saying again. Before we just did a bunch of them that were all x's, right? So it was just x squared or x to the 4th. Now we have a number in here that makes our combinations of x's have possibilities, just like our constants did. So we have that product idea for both the beginning and end term that we have to consider. That's why it gets harder. Okay, so what do you notice about the factors leading coefficients? It's 3 times 5, which is 15, same as the start. So we're talking about these guys, 3 times 5. How do the zeros relate to the coefficients of the polynomial? So they are the what? The 3 is the bottom. The 5 is the bottom, right? They're the denominator. So the numerators are the zeros of the constant. So what I'm saying here is, up here we got 2 and 8. Those zeros, or whatever, the constant, just the constant, don't forget the 3, is the numerator. So this was 2 on the top for 2/3. And then the denominator is the coefficient of the x values. Okay? All right, so let's look at B here. So B says the factors of polynomial 10x cubed plus 81x squared minus 298x plus 231 are, they tell you, 2x minus 3, 5x minus 7, and x plus 11. State the zeros of the polynomial function. 3 over 2, 7 over 5, and -11. What do you notice about the constant term and the polynomial and the constant term in the factors? So what they're saying is, what do you notice about the 3, -3, -7, and the 11? Well, when you multiply those, you get what? The 231. What do you notice about the leading coefficients? So you got 2x times 5x times x, you get 10x cubed. So what I'm saying is once you get it, okay, you're going to see that you can check your work pretty easily in terms of the ends. How do the zeros relate to the coefficients in the polynomial? So this is the same thing they just said. So the numerator, you can just draw an arrow up if you want, if you're not feeling like you want to rewrite it. But the numerator, again, of the zeros is the constant. The denominator is the leading coefficient of the x term. Leading coefficient is the x term, but just so you know what it means. Okay, because leading coefficient's remember, leading coefficient's the number in front of the biggest variable, like the highest degree. Well, in these binomials, highest degree is 1, right? So leading coefficient's 2, 5, and 1. Okay, the examples above illustrate of the rational zero theorem, which states that the zeros of an integral polynomial function p of x are in the form of p over q. So p over q is your p and q, where the numerator p is the factor of the constant term, and the denominator is the factor of the leading coefficient. So this is what you want to have down. Okay, so circle this. The possible zeros for your answer, if these guys are a little bit harder, is the factors of the constants over the factors of the leading coefficient. Leading coefficient is the number in front. Okay, so that's how you figure it out. That's your possible ones. So does that make sense? So this kind of goes in, we're going to be trying fractions now. Right? We're going to be trying 3 over 2, seeing if 3 over 2 works. If 3 over 2 works, what's that factor? Remember, you got to think, oh, 3 over 2. So 3 over 2 would mean it's going to be minus 3, 2x, right? Add the 3, divide the 2. We'll get used to that pattern as we do it. Okay, so let's look at this one. Consider the polynomial 5x cubed minus 51x squared plus 55x minus 9. So the factors of the constant term, the negative 9, is plus or minus 1, plus or minus 3, plus or minus 9. The factors of the leading coefficient are plus or minus 1 and plus or minus 5. So our possible zeros are these, and then we can simplify those. Right, so what's 1 over 1? 1. What's 3 over 1? 3. 9 over 1? 9. 1 over 5? 1, 5. 3 over 5? 9 over 5. So we had 6 options, right? Technically 12 options, but 6 plus or minus options once we simplified. Okay. Questions on that? That's the meat of what we're going to do. So if you don't understand what p over q is, please ask now. So again, p is the constant multiples. Q is the leading coefficient multiples. Okay? So want to see an example? Okay, so we're doing the one that they just set up for us, so we kind of already know. So it says consider the function, the one we just talked about. Use the potential zeros above to list the binomial factors. So what are the possible factors? So they want us to list them. Okay, we're only doing 2 examples here, so just hang in there. Your possible factors are x minus 1, x plus 1. Okay, we have x minus 3, x plus 3, x minus 9, x plus 9. That's the whole numbers. And then 1/5. 1/5 would be 5x minus 1 and 5x plus 1 to get plus or minus 1/5. 5x minus 1, 5x plus 1. That's the 1/5 if you look above there. The 3/5 would be 5x minus 3, 5x plus 3. Plus 3. Okay, and the 9/5. 5x minus 9, 5x plus 9. So those are my possible zero factors. So it says, show that x equals 1 is a 0. So we're going to show that x equals 1. So we're using synthetic division. So we got 1. We'll put the 1 in, which is this one. This represents that factor. Okay, so from here, it's 5 negative 51, 55, and negative 9. We drop the 5. 1 times 5 is 5. That's negative 46. Okay. Negative 46 and 55 is 9. 1 times 9 is 9. 0. So it is a factor. What's that? Yeah, so we're going to finish it. Yep. And so it wants me, and then now it says determine all the zeros. So we're going to determine all the zeros from this. Right here, we have 5x squared minus 46x plus 9. So now we're into quadratic land. Okay, yeah. Now, this is where some of you guys are still forgot your math 20. You need to be able to factor this. This is decomposition. So you go 5 times 9, right? Remember? 5 times 9 is 45. What are factors of 45 that get you 46? Negative 46. Negative 1, negative 45. Okay, if you learn factor a different way, then do your boxes or whatever. But this is how, if you had me, this is how I taught math 20. Rainbows. Sure, do rainbows is great. Okay, so here we go. We're going to go 5x squared minus 45x minus x plus 9. We group. So what I did was, I took the 46 right here. If you're not sure of the process, you want to be reviewed. You're taking the 46 and you're breaking it up into two terms that we can factor by grouping. Because negative 45 and negative 1 is still what? Negative 46. We're not changing anything. We're just rewriting it so that we can factor. So what does the 5x squared and the 45x have in common? A 5x. So that's going to be x minus 9. Since this is x minus 9, we want this to be x minus 9. It's just a little bit off, so we're going to pull a minus 1 out. That gets me x minus 9. It's now factored. So your complete answer is going to be x minus 1, the one we got in the original they gave us, 5x minus 1, and x minus 9. That's it factored. So your solutions for C are 1, 1/5, and 9. Okay, questions or concerns on that? I know a lot of you are like, oh, shoot, I forgot how to factor. Okay, we need to work on that. Ask for help. Let's do some stuff after the video and get you factoring good again if you forgot. Okay, all right, let's try the last one here. Last problem. Okay, so determine all real solutions of the equation 2x cubed minus x squared minus x minus 3. Okay, so all real solutions. So we want to figure that out. So what do we got to do first? Well, we got a 2 and a 3. So we want to go, they gave us a nice one. Why? Because 3 and 2 are pretty cool because it's just 3 and 1 and 2 and 1. Right? So I want to do multiples of 3, which is plus or minus 1, plus or minus 3, over plus or minus 1, plus or minus 2. Right? Those are my options. I did P over Q. So my potential zeros are the following. Plus or minus 1, plus or minus 3, plus or minus 1/2, and plus or minus 3/2. That's my only potential zeros. I only have 8. Okay. 1 over 2. Got to do both of them. Am I just doing what? Oh, yeah, we'll just, I guess, you're going to have to test them. It's not going to work at some point, okay? I would just suggest when you're testing, just go ahead and test in your calculator. Let's do this. I'm going to show you. This is how you want to do in your calculator test. This is going to go away for a second, so hope you have this. What I would do is, if I were you, I would go to test. This is the easiest way. Go ahead and build, let's just try 1. So I'm going to go 2 bracket 1 bracket cubed. I'm going to go minus 1 squared. Okay, minus bracket 1 and minus 3. And so I have the 1 in there, okay? And so I'm going to hit enter. Okay, not a 0. Okay, but instead of just writing it all out, this is what you want to do. Go second entry, and now go replace the ones with the new one you want. You guys got that? So now I'm going to put in the one that's going to work.
How do you do that with anyone else gives 0? How do you do that with -c?
What's that?
How do you do that with -c?
Like putting in a negative? Or what do you mean? So, right, so if you want to put in -3, you're going to go over here and you have to do insert. So you go second. So right, we don't, like if he wants -3, so he's saying I put in a negative, it moves on that bracket. See that? We don't want that, right? So let's go second INS 3. It puts it in the bracket for you like that. Okay, so we can go, let's go do -3, see if -3 works. Okay, so you go negative, second, insert 3. Negative, second, insert 3. All right, so that's all for the -3. Enter. That one's still not a 0. So -3 doesn't work either. Okay? Okay, let's do the one that I know that works here. Let's do 3. Right here on second delete. Okay, so second entry. Now I'll put in a fraction too, so you can see that. I'm going to put in, the one that does work is 3/2. So let's go do 3/2 here. So hit 3 divided by, okay, so you see I'm out of room. Second, insert 2. That's how 3/2 is in there. Three divided by, I'm out of room. Second, insert 2. Yep. Go ahead. 3 divided by, second, insert 2. Okay, so there it is. Enter. 0. Perfect. So 3/2 is a 0, so we're happy. Come down here. We know that we got 3/2. So when we write 3/2, 3/2 is, okay, that for a factor is going to be 2x minus 3. Okay, we will go ahead and synthetically divide it so we can figure out what the quotient is. So we're going to divide 3/2 synthetically. 2, -1, -1, -3. Bring the 2 down. 3, -2, -3. Wait. 2, -3. That's right. Oh, it is just going to be, no? Yeah, you're right. No, hold on. 2. That's 2. Yeah, you're right. I got you. So that's just 3. Thank you. 2. And then we get the 3 again. Okay, so 2, 2, 2 is what we have. So we have left over is 2x squared plus 2x plus 2. Okay, so we have to use decomp on this, but we can't because 2 times 2 is 4. So darn it, 4 doesn't get into factors of 2 ever. So we have to use quadratic formula. Okay. So -2 plus or minus 2 squared minus 4 times 2 times 2. So that's going to be, this is cool, actually. Okay, so 4 times 2 times 2, 16. We're done here, but we'll do the bottom just so you can see it. Okay, we're done because that's a -12. What's that mean? Can't do it, but what's that mean in terms of your discriminant from Math 20? There's not, right, no solution. Okay, so that means it doesn't cross. Okay, so that means this cubic probably looks like this, just for understanding of the picture. So that cubic probably looks like this. It doesn't come back down across. And so you get no solution. Okay, so that means, so the problem with that is there isn't zeros. So your actual, when this happens, to write down it factor, saying, well, how do you write it factor then? It's going to be 2x minus 3 with this. That's all you can do because this can't be factored. right? So this is your answer for it being factored. That's as far as you can go. Okay? Any questions? You could pull a 2 out of here if you wanted, they said, but it's up to you. Okay, we'll stop there.